Hello, friends. In continuation with the previous videos on gate problems, we are going to continue further. This is the problem on single underreamed pi. This problem was asked in gate 2011. A very interesting problem. This single underreamed pi is embedded in a stiff clay, as it is shown over here, and the properties of the ground is given to you. The undrained cohesion is 50 kilopascal. The adhesion factor alpha is given as 0.3, and the bearing capacity factor is given as 9. The weight of the pile, WP, is 20 kilonewton, and we need to calculate the ultimate tensile capacity of the pile. So this is the tensile capacity of the pile when you pull it. What is the pull-out capacity of a single underreamed pile is called the ultimate tensile capacity of the pile. So when the pile is pulled, then the skin friction will be acting in the downward direction, as can be shown over here. So the skin friction has to be calculated, which will be acting over the pile shaft in the downward direction. And there is a bulb, single underreamed bulb. So when you pull it, there is going to be soil resistance here. It will be offered in the downward direction over the bulb or over the underream of the given pile, and you need to calculate the value of QUT. Naturally, here the weight of pile is also given to you. The weight of the pile will pass through the CG. So WP is the weight of the pile. So what are the forces that's going to come into picture in the downward direction? One is the skin friction that's acting over the pile shaft. So the ultimate tensile capacity, Q ultimate or QUT, we can write it, will be given by the skin friction, which is acting over the pile shaft. This is acting in the downward direction, and this is the tensile capacity plus. Now, over the bulb, the resistance is being offered. So, over the bulb, what is the resistance offered by the bulb? That is also acting in the downward direction, plus the weight of the pile is also acting in the downward direction. So this is the expression that you need to use it to find out the value of ultimate tensile capacity of the pile. Now, as you know, this QS is going to be unit skin friction multiplied by the shaft area. So please calculate this. Fs is going to be alpha times Cu, and the shaft area is going to be pi d into L. Now the diameter of the pile is given to you here as 0.35 meter, and the length is given as 8 meter. So this is the diameter of the pile and this is the length of the pile, and therefore we will be in a position to calculate this value of Qs in kilonewton. So alpha value is given as 0.3. So it becomes 0.3 multiplied by the value of Cu, which is 50 kilopascal, into pi into diameter is 0.35 meter, multiplied by the length is given to you as 8 meter. So this will be value in kilonewton. So you calculate this. And the next term is QB. So QB, here the resistance is being offered. It will be CNC or CUNC. The resistance is being offered in the downward direction, and it is acting over the area of the bulb, where AB is called area of the bulb. So this will be, NC is 9, so you can say 9 times Cu is given to you as 50, and area of the bulb over which this soil resistance is going to act will be pi by 4 diameter of the under ream whole square minus diameter of the shaft whole square. So what is the diameter of the under ream? This is called diameter of the under ream, which is given over here as 0.75 meter. So I can easily substitute all the values and I can calculate it. This is going to be 450 into pi into du is going to be 0.75 meters square minus, this should be deducted, the shaft diameter, which is equal to 0.35 meter whole square divided by 4. So this you can calculate. This will be also in kilonewton. So this you can calculate. And the last term is already given in the problem as 20 kilonewton. Therefore, you will be able to calculate the value of QUT. So let me take my calculator and calculate all the values. First QS, so this is going to be 15 multiplied by this gives me 131.94 kilonewton. And the second value is QB, that's going to be 450 multiplied by pi into 0.75 square minus 0.35 square. This gives you 155.5 kilonewton. So therefore, Q ultimate, we can calculate the tensile capacity as plus 131.94 plus the weight, that is 20, This gives you 307.44. So on substitution in equation 1, you can get the value of tensile capacity ultimate of the underreamed pile. So this problem you can do it very nicely by going conceptually. What are the forces that comes into picture, and how to find out those forces, and then applying the basic concept, it is quite simple to calculate this. So I hope you understand this. I will go to the next problem now. My next problem is of 2009, and the problem is using a modified Healy's formula, you will have to find out the ultimate resistance of the precast concrete pile. So we have to find the ultimate resistance of a precast concrete pile which is driven with a uh, hammer. The weight of the hammer is given as 50 kilonewton. So you have a pile and you have a hammer. The weight of the hammer, WH, and the height of the fall will be capital H. So weight of the hammer is given to you, and the height of fall of the hammer is given as 1 meter, or you can say in centimeter, it will be 100 centimeter. The efficiency of the hammer, eta, is taken as 60%. So 60% means 0.6. So eta equal to 0.6. So the efficiency of the hammer is 60%, and the set per blow, is given to you. Set per blow, you can write the symbol also. It is given as 4 mm, that is in centimeter, it will be 0.4 centimeter, and the compression of the dollies, the compression of the pile top and all soil, C equal to, that is given as 6 mm, that is, this is 0.6 centimeter. So C is also given to you, and you need to calculate the ultimate resistance of the precast pile. So how will you calculate the ultimate resistance of a precast pile? Let's say the ultimate resistance of the precast pile is QR. QR is the ultimate resistance of the precast pile. This is given by modified using, you will have to use using modified Healy's formula. So this is given as weight of the hammer multiplied by the height of fall of the hammer multiplied by the efficiency eta divided by set plus C by 2. So this is the formula. Or we can say this is equal to weight of the hammer is given to you as 50. So 50 multiplied by H is 100 centimeter, eta is 0.6, and the set per blow is 0.4 centimeter plus the compression is given as 0.6 by 2. So this, if you simplify it, this becomes 5,000 multiplied by 0.6. So this becomes 3,000 and this becomes 0.7. So this will be the value. It is in kilonewton, therefore the ultimate resistance of the precast in kilonewton can be computed. So if we compute it, $3,000 4285 0.71 kilonewton. Very simple problem. If you know modified Healy's formula, all the related data are supplied to you in the examination, and therefore you can solve easily the problems. Now the next problem will go. So next gate problem is of 2007, and this problem is to find the ultimate load carrying capacity of the pile group. So you have a pile group. So find the ultimate load carrying capacity of the pile group. Assuming the group to fail, assuming the group to fail as a single block. So it is a block shear failure. That means it is a group shear failure or block shear failure. The piles data are given to you. Data are diameter of the pile is supplied to you as 0.4 meter, and the length of the pile is also given to you as 10 meter, and this pile group is embedded in a cohesive soil bed. So soil properties are also known to you. The value of Cu is given to you as 40 kilopascal. So you know the value of Cu, and the center to center distance between two consecutive pile is 1.2 meter center to center. So that's also supplied to you. And the number of piles are 4. So it is 2 by 2 equal to 4 piles in a square pattern. That means, quite simple now, this problem gives you that you have got the pile arrangement like this. This is the problem, and this problem needs solution. So ultimate load carrying capacity of the pile group, that means I need to find out QUG. U means ultimate, G means for the group. This QUG based on block shear failure will be given as perimeter of the group multiplied by the length of the pile. So as a block it is going to fail. So here the unit skin friction is going to come into picture over the periphery. So plus F into Fs and plus the end bearing resistance is going to act over the area of the group, which will be width of the group in a square pattern. It will be whole square multiplied by unit end bearing resistance. So there is the formula based on block shear failure. So when as a single block it is going to fail, there is the formula, and there is the pile. In the plan it looks like this. If you draw it, it is going to be quite simple now. So one pile, the sectional view, if you take it, it will look like this. So there is the pile embedded in cohesive ground, and you need to calculate the value of QUG. So when it is going to fail as single block, the unity skin friction or the shear lines will get developed over here. This is going to be act as a one unit, monolithic unit. So soil within this will be the part of the pile, and the unit skin friction will come over the periphery. So this Fs is going to act over the perimeter. So this is the perimeter. So you can find out the perimeter. It will be 4 times width of the group. So find out the width of the group. the center to center distance is given to you as 1.2 meter. So plus the diameter. So width of the group will be how much? You can calculate the width of the group. The width of the group will be 1.2 plus d, and the diameter is 0.4, so it becomes 1.6 meter. So 4 into bg, this becomes perimeter of the group, and the length is also given to you. So you can calculate this. Here Fs will be Cu in block shear failure, and the value of Cu is given to you. Therefore, calculate the value of QUG from expression 1. Therefore, the ultimate load carrying capacity of this pile group is going to be 6.4 multiplied by the length multiplied by Cu, which is 40, plus Bg, we have already calculated, multiplied by QE. At the end, it is 9 times Cu. So multiply it 9 into 40. So on substitution in expression 1, we get the values based on block shear failure. Let us calculate this. So if I calculate, it's quite simple. This is 3,481.6 kilonewton. So you can see how simple it is. So all problems I find that it is conceptually, this is the answer. You can calculate very easily the value of QUG based on block shear failure. These things I have explained also in theoretical part in my videos, and if you want to go in detail, though I have explained you conceptually over here, you can refer those videos also. So friends, we will go to now next problem of pile that's going to be of 2006. So next problem, gate problem, that is going to be quite interesting. So the next problem is 2006, and the 2006 problem is we have to find the number of piles in a required in a group to find the total number of piles, total number of piles in a group for the following data. This 2000, get 2006 problem. So what are the data? They have given you the piles data. The diameter is given. Also the length is given. The diameter is 0.3 meter and the length of the pile is also given to you as 10 meter. And the load that is coming over the pile group, the load applied, that is QA, is given in this problem as 5000 kilonewton. So you have the load also, and the factor of safety is given FOS, factor of safety, equal to 2.5 as per IS 2911. It is 2.5, and the efficiency of the group, pile group, is taken as 100%, that is 1. And this pile is embedded in a stiff clay. So the properties of the soil is also known to us the medium stiff clay. It is medium stiff clay, and in the medium stiff clay the value of Cu is 100 kilopascal, and the value of alpha is 0.57. So if you draw the pile, so when it is embedded into the ground, so ground surface, medium stiff clay, the properties already given as 100 kPa and alpha as 0.57, and here at the bottom it is a stiff clay. It is a stiff clay with Cu equal to 150 kPa at the bottom, at the tip of the pile. So with these informations, as you know, you have to find out the total number of piles, that is capital N. So how will you find out? It's a very, very simple problem. So based on individual shear failure, you know it, I have already explained this. Based on individual shear failure, and the pile is going to fail one by one, the ultimate load carrying capacity of the pile group is given by the expression, the number of piles, capital N, into ultimate load carrying capacity of single pile into the group efficiency factor. So this factor, this is the expression to be used. Now you have been given the allowable load over here and factor of safety. Therefore, the value of QUG will be definitely factor of safety multiplied by the allowable applied load. So it becomes 5000 multiplied by 2.5, so much of kilonewton. So there is known to be. This I want to calculate. This I can calculate. So please calculate the ultimate load carrying capacity of single pile. This is known to be, this is 1. Now what is the ultimate load carrying capacity of a single pile. There is, for a single pile, it is alpha times Cu multiplied by pi dl. I've already explained pi d multiplied by the length of the pile, and there is the unit skin friction plus 9 times Cu into pi by 4 d square. So this will give you 0.57 into Cu is given to you as 100. Take it as 100 into pi, and the diameter of the pile is already mentioned as 0.3 meter. So 0.3, and the length of the pile is already mentioned as 10 meter plus 9 into this. Now, here this QE will come into picture here. But there is a stiff clay now, this QE, which is 9 times Cu. So this Cu value has to be taken. So 9 times 150 into pi into d square. Diameter is already given as 0.3 meter. So I will take it as 0.3 meter whole square divided by 4. So if I calculate this, I will be getting this value. So let me calculate. So if I calculate this, 0.57 plus this gives you 632.63 kilonewton. Single pile. So this value I have calculated. So therefore, the ultimate load carrying capacity of the pile group equal to number of piles which I want to find out multiplied by 632.63 into 1. Now QUG is already 12,500. So 12,500 divided by 632.63 equal to the number of piles required. So let me calculate this. This is 19.758 piles. So the number of piles, therefore you can provide number of piles required equal to 20. So this is the answer. So this problem here, total number of piles in a group, capital N, is going to be 20 piles. So friends, this problem, I hope you have understood it in totality, and I have tried to make it as simple as possible. Now we will go to the next problem. We'll try to cover up all the problems that can be asked and that have been those problems which have been already asked in previous examinations of GATE, that we can do it. I have left the similar problems because of paucity of time, and those problems in details, we have those problems which are of similar nature. I'm not going to touch upon because it's already explained. Uh, so now I'm going to have to calculate the settlement of the pile group. There is 2003 GATE 2003 problems to compute the settlement of the pile group. To compute the settlement of the pile group embedded in normally consolidated clay. And the properties of the normally consolidated clays are given as Cu equal to 100 kilopascal, and the saturated unit weight is given as 20 kilonewton per cubic meter, and the compression index of this normally consolidated clay, Cc, is given as 0.027, and the original void ratio is E naught 1.05, and the load applied over the pile group is 500 kilonewton. So this is the total load that has been applied. The piles data are also known to us. It's a pile groups 3 by 3 equal to 9 piles in a square pattern. That's given to you. That's 9 piles. The length of the file is 5 meter. L equal to 5 meter. And the diameter of the pile is 0.2 meter. So diameter is also given to you. And the center to center spacing between the pile is also given to you as 0.5 meter. Center to center between the two consecutive piles. So with these informations, and the figure is also given over here, the figure I will draw it for a better understanding of all of you, is given to you like this. One pile, second pile, and this is the third pile. So this is the sectional view, 3 by 3 piles, and this is the tip of the pile, and the length of the pile is given to you as L equal to 5 meter. So length of the pile is given to you, and up to after 7 meter there is a hard stratum. So this is the hard stratum. So that's also given to you. So the number of piles, you can see 1, 2, 3. There is the pattern, 9 piles. There is the square pattern. This is the plan view, this is the sectional view. So this is there, and the load that is being applied over this pile is also given to you as Q equal to 500 kilonewton. So you need to calculate the settlement in normally consolidated clay. SC is given as CC divided by 1 plus E naught into H into log of sigma naught prime plus delta sigma prime divided by sigma naught prime to the base 10. So here in this problem, because it is uniform clay, now find out the load will be transferred at a 2/3 of L. So 2/3 of L will be so load will be transferred here. This is the imaginary footing, and load is going to spread like this. 2 vertical, 1 horizontal. This is how the load is going to spread out. So 5 minus 3.3, the 1/3 of L will be 1.67 meter. Right? So this distance becomes 1.67. And this distance is going to be 2 meter because it is 5 meter and up to 7 meter from the ground level, this hard stratum comes into picture. So from here up to here, it is 7 meter, and so this is going to be 2 meter. Now, at the center of this is going to be H. This is the zone in which the load will be felt. So here, the value of H is going to be 1.67 plus 2 meter. So it becomes 3.67 meter. So H is known. CC is given. E naught is given. Now, the sigma naught prime. What is sigma naught prime? It is the effective overburden pressure at the mid point of the layer which is going to be compressed. So at h by 2, you calculate the mean value. So the mean value will be at the midpoint. So the distance will be 3.33 plus. At the midpoint, it is going to be h by 2, that is 3.67 divided by 2. So that is the distance from the ground level, from GL. So from GL, the midpoint of this H is going to be 3.33 uh, plus 3.67 divided by 2 multiplied by the unit weight submerged unit weight. Now, what will be the submerged unit weight? The saturated unit weight is given to me minus unit weight of water. So, I can find out the value of gamma prime will be 20 minus 9.81. So, this is going to be 10.19 kilonewton per cubic meter. So I can calculate it very easily. This becomes 10.9. So the effective overburden pressure can be calculated. Now, the another term, so we can calculate this, is after application of this 500 kilonewton of load, when you construct the pipe and from the superstructure, post construction, what is the increase in pressure at that midpoint of the compressible layer? So you need to calculate now delta sigma prime, which will be the load 500 divided by. Now at h by 2, it is load is going to spread at 2 vertical, 1 horizontal. So first calculate the width of the group. The width of the group, now center to center distance must be given over here. So it is going to be 0.5 meter center to center. So 0.5, 0.5, this is 1. And D is also given in this problem as 0.2. So BG becomes 1.2 meter. So it is going to be 1.2 meter, that is BG plus. What is this? H by 2 is going to be 3.67 divided by 2. So it will be 3 at the midpoint will be 3.67 divided by 2 whole square. So this also you can calculate in kilopascal. So delta sigma prime you can calculate and substitute. So let us calculate. I hope you understand. At the midpoint, you need to calculate the, so if I calculate for 3.67 divided by 2 or 0.5 into 3.67 whole square. This gives you 54.281 kilopascal. And this also we can calculate. This is going to be 3.33 plus 3.67. This gives you 52.63. 631 kilopascal. So all the values being known, now we can substitute in this formula and get the value of settlement of the pile group SC. So SC is very simple to be calculated. You need to calculate the width of the group, which is here, BG, and you can calculate this. And therefore, let us now substitute. So CC is given 0.027 multiplied by H. So H is 3.67 multiplied by log of sigma naught prime plus delta sigma prime. Sigma naught prime is 52.63 plus 54.28 divided by 52.63. Divided by 1 plus E naught. E naught is given to you. So this becomes 1 plus E naught, 2.05. This gives you the value of SC. So therefore, I get this value. Therefore, I get the total settlement of the pile group as 0.0148 meter. So in millimeter, 1, 2, 3. So friends, this is the answer. So we have been able to calculate the value of SC as 14.8 millimeter for this pile group. In the previous videos also I have explained how to compute this particular this. If it is, if you, because it is one thing I would like to highlight, what is the value of H? H is more than 3 meter. So if you refer IS 2911, you should divide this into 3 layers. So this H should be divided into H1 plus H2 plus H3. So this 3.67 meter, you can take 1 meter, 1 meter and last one as 1.67 meter. And at the midpoint of each layer, by using this expression, you can calculate the constellation settlement, and then finally SC will be SC1 of layer 1 plus SC2 plus SC3. This video I have already explained earlier. So you should go that way, because IS 2911 talks about that this should be divided into, this H should be divided into 3 layers, at least 3 layers. So H1, H2, H3. Now total H is 3.67. So H can be taken as 1 meter, H2 can be taken as 1 meter, and S3 can be taken as 1.67 meter. And at the midpoint of all the three layers, let's say I've divided into, so midpoint, 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 you calculate at the midpoint of layer 1, layer 2, layer 3, the value of delta sigma naught prime and delta sigma prime for the given intensity of loading. So you can calculate SC1, SC2 and SC3. So that approach should be followed. I have explained it conceptually earlier also. So please refer that video also. This has been completely explained to you. With this, a very big chapter on deep foundation, that is pile foundation, has been completed in all respect. If I come across any new kind of problem, definitely I will explain to you conceptually, and how to attempt those problems, I will let you know. So, friends, I hope you have uh, you have had very good experience. Please give me your feedback, and you can, if you have not subscribed, please subscribe so that you get the future videos. Now I will be going to the in foundation engineering, the previous gate problems on other topics. So very shortly we are going to come and complete syllabus of foundation engineering and geotechnical engineering. Thank you very much.